Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning program. I'm teacher Pasco, and today I will be with senior 2 students learning chemistry. In the previous lesson, we discussed the types of solutions. And today we will continue with the same unit, preparation of salts and identification of ions, but with a new lesson that I will tell you the title very soon. Before we start our lesson, let us have some questions of revision. What is a saturated solution? We explained that. So try to recall what is a saturated solution and state the 2 components of a solution. You have 1 minute to think about that. All right. Answers? A saturated solution is a solution which cannot dissolve more solute at a given temperature. So if you add more solute, it will not dissolve. A saturated solution is a solution that doesn't dissolve more solute at a given temperature. And the 2 components of a solution, we have a solute and a solvent. Today, we will discuss the factors which influence solubility. I think you all remember what solubility is. How do we define solubility? Try to think about it. What is the definition? How did we define solubility? So today's lesson is the factors which influence the solubility of salts. And I have asked you to try and recall what is the definition of solubility. Solubility is defined as the amount of a solute that can be completely dissolved in 100 grams of a solvent at a given temperature. Solubility is the maximum amount of solute that can be completely dissolved in 100 grams of a solvent at a given temperature. Good. Now I have a question for you. Here we are saying that it is the amount of solute that can be completely dissolved in 100 grams of solvent, but we add at a given temperature. At a given temperature. Even here we have added at a given temperature. Why do we always to consider that solubility at a given temperature? And we make clear definition of that particular temperature under which we are working. It is because temperature is one of the factors which influence solubility. When you change temperature, you also change the solubility. And that is what we are going to analyze. How does a change in temperature affect the solubility of a given salt? Temperature will not be the only factor we will discuss today, but it is the one we are starting with. Suppose that you have 2 cups of tea. You have hot and cold tea, and you are about to add some sugar to both cups. In which cup do you think sugar will dissolve faster? Try to think about it. You have hot tea, cold tea, and you're about to dissolve, to add some sugar in your tea. In which cup do you think the sugar will dissolve faster? Let us use the experiment to demonstrate what will happen. And here we will use cold water and hot water. The cold water to represent the cold tea, and the hot water to represent the hot tea. Hot water, and here we have the cold water. And here also we have the solute we are going to use. So for our solutions, we are going to prepare the cold and the hot solution. We will use water as the solvent and copper sulfate as the solute. This is copper sulfate. You remember its color. It's blue. Now let us see what happens if we add some solute to both cold and hot water. We have to wait until the water is somehow hot. And another question, why we are waiting for this water to be hot enough, the first factor is temperature. And the second one will be the size of solute particles. Now let us add some solute to both solutions and see in which solution will the solute dissolve faster. Do you observe any difference? We have more undissolved particles in the cold water than in the hot water. So in the hot water, you can see that solubility is higher than in the cold water. So solubility increases with the increase in temperature. When you reduce temperature, solubility also decreases. As temperature increases, solubility increases too. And when temperature drops or decreases solubility, decreases. Why is it like that? It is because when you are providing heat and the decomposition of substances requires heat, then you are favoring the decomposition of the solute, which will dissolve more. And when you reduce temperature, you will be favoring the recombination of the substance. And in that case, you reduce solubility. Now, what happens when we use small particles, solute particles, or large solute particles? What happens? Let us have a look. We have two test tubes here, and the one contains large particles, while the other one contains small particles. You can also think about what happens when we are about to add some salt in food. When we use large particles of table salt, and when we use very small particles of table salt, what kind of particles dissolve faster? Have you ever tried to do that? When you use large particles, what happens compared to when you use small particles? Let us have a look. We will add some water. Let's use this, which is called and we mix. You can see what is happening. In this test tube, where we have large particles, the large particles are still there, but the small particles have completely dissolved. So solubility increases when we have small particles, because we have a lot of particles which have a large surface to be in contact with the solvent. So small particles will always dissolve faster than large particles. You can see the large particles are still there, but the small particles have completely dissolved. I think this is very clear. So, small particles dissolve faster than large particles. This is because the small particles have a larger surface to be in contact with the solvent molecules. Factor number 3 is nature of solvent. And how does the nature of solvent affect solubility of salts? We have different types of solvents. We have explained that when we were studying the ionic bonding and covalent bonding and comparing the physical properties of ionic compounds and those of ionic covalent compounds. We have seen that ionic compounds are insoluble in organic solvents, but soluble in inorganic solvents, such as water. Hope you remember that very well. And we have seen that covalent compounds are soluble in organic solvents, but insoluble in inorganic solvents, such as water. Now we are going to demonstrate that. Does it really work like that? Let us have a look. We will use water as the inorganic solvent and hexane as the organic solvent. What happens? Here we have our solute in the two test tubes, and we have the two solvents. Let us add water and see what happens. And here we have the organic solvent, hexane. We have the two solutions, or the two mixtures. What happens when we mix? Let's have a look. You can see that this solution, where we have water as a solvent, it is becoming blue, and the solute particles are disappearing. So the solute or the salt is dissolving. But here there is no dissolution. The solute is not dissolving. Why? Because we have an inorganic solvent. This is hexane, and this is water. So depending on the nature of your solvent, a solute can dissolve or not. Salts are soluble in inorganic solvents, but insoluble in organic solvents. Salts are insoluble in organic solvents, but soluble in inorganic solvent, such as water. For the organic solvent, we have used hexane. And the fourth factor is the concentration. Concentration of solution. Do you remember the saturated and unsaturated solution? What is the difference between the two solutions? The unsaturated solution can dissolve more solute, but the saturated solution cannot dissolve more solute. And that shows how the concentration, which is the amount of solute present in a given volume of solvent, can affect the solubility of solute or of a salt. So if your solution is saturated, to mean that it contains more solute, it cannot dissolve excess solute. That is the saturated solution. But if your solution is not saturated, then it can dissolve more and more salt or more solute. Concentration of solution. Saturated solutions cannot dissolve more solute. So as concentration increases, solubility decreases, and vice versa. So if the concentration increases, the solubility will decrease. But if the concentration decreases, then solubility increases. As the amount of solute is decreased, or if you have a small amount of solute in a given solution, then you can dissolve more solute. But if you have already dissolved more solute, it will be very hard to dissolve more and more excess solute. It's not possible. And the other factor, but which applies on gases only, is pressure. but pressure doesn't affect the solubility of salts. So pressure is another factor, but which cannot affect the solubility of salts. It affects the solubility of gases only. So when pressure increases, you are applying a force to the solute particles and forcing them to be dissolved, to mix with the liquid. So as pressure increases, the solubility of a gas increases too. But when pressure decreases, solubility of a gas decreases. Let us take the example of a bottle of soda. You know what happens when you open it. You can start seeing the air bubbles coming up. Why do the air bubbles come up? Why do you see them when the bottle is open, but not when the bottle is closed? It is because when the bottle is closed, inside the bottle there is a very high pressure, forcing the gas particles to be dissolved in the liquid. But when you open the bottle, the pressure reduces, and then the gas particles start to come up as the pressure decreases. And that is very clear, I think. You will check on that. When you open a bottle of soda or beer, you can see the air bubbles coming up. That is because the pressure has been reduced, and now the gases or the gas particles can escape very easily. Now, before we go to the assignment, let us have a look at the main points you have to remember. The main points to remember, here we have the meaning of solubility. We have discussed this earlier. And for particles, we have temperature. What happens when temperature increases to the solubility of salts, or when it decreases? Increasing temperature increases solubility, and decreasing temperature decreases solubility. And what happens to the size of the particles of the solute? For a big particle, the solubility is slow, but for a small particle, the solubility is fast. Nature of solvent: organic solvents will never dissolve ionic compounds, the salts, but inorganic solvents do dissolve salts. And the concentration, we said that as concentration increases, the solubility decreases. Now let us have an assignment, a homework you will do. Explain why solubility increases when temperature increases. How does solubility change with the change in concentration? Explain how the size of solute particles affect the solubility of salts. And number 4, explain how a decrease in pressure will affect solubility Explain why solubility increases when temperature increases. That is the first question. How does solubility change with the change in concentration? That is the second. And the third, explain how the size of solute particles, whether large or small, affects the solubility of salts. And finally, explain how a decrease in pressure will affect the solubility of a gas in a liquid solvent. Thank you very much for your attention, and I hope to see you next time for the next lesson. Thank you very much.